Hello everyone, welcome back to my channel. Let's continue the series of lecture on data engineering using AWS Cloud. Let's first recap what we learned till now. So till now we have created one streaming flow using Amazon Kinesis Data Stream, Amazon Kinesis Data Firehose or the delivery stream and the S3 bucket. And when we produce the data from our producer node, which is nothing but our machine, we get the data in the near real-time basis in our S3 bucket. So that's how our streaming flow work. This streaming flow allows us to stream data into our S3 bucket in near real-time basis. I would recommend you to first go and watch that video if you haven't watched it yet. I will provide the link of that video in my description below. Also, you can go to that video directly by clicking on the I button on top right corner of your screen. Now let's go to the next chapter of our series in which we would be querying that data using the AWS Athena engine. So right now we have our data in our in S3 bucket in JSON format, but that data we are now having in the JSON format, and that data is not easily queryable. So we would need some kind of the engine to allow us to draw some meaningful insights and the information from that data. But before looking into that, we first need to understand the concepts of partitioning. Because if our data is not rightly partitioned in the S3 bucket, it may lead to the slow runtime of our query on top of the S3 data. Or also the Athena needs to scan a lot of data to find out the meaningful information in our S3 bucket, which may uh, increase the cost of our AWS cloud or the cost of our S3 bucket itself, because Athena internally uses the S3 APIs to query that data, and it costs the amount of rows it scans for one query. So we need to reduce the number of rows as well, which is required to scan to find out the meaningful information. And also we need to develop a efficient system so that the information can be drawn as fast as possible. So for that, we need to first understand the concept of partitioning. So let's first go to our Amazon account and see how the data is currently partitioned in the S3 bucket. So I'm in my AWS account, and let's go to the S3 bucket very quickly. And we have this S3 bucket raw data in which the data is partitioned on the basis of the year, month, date, and then the hourly basis. And then we have our data in the JSON format under this partition. And we can query this data with the S3 select as of now and see how our data is actually looks like. But the drawback of this kind of partitioning is that first, this kind of partitioning is not very much efficient because it may lead to the increased costing as well as the slow runtime of as well as it will increase the runtime of the query, and our system will not work as efficient as possible. So we need to avoid this kind of the default partitioning. So let's first understand the concept of partitioning in the uh, S3 bucket. So we have the two types of partitioning mechanism. One is the inline parsing and second is the AWS Lambda function. So as of now, we have our data in the JSON format. So I would recommend to go with the inline parsing in this video. If you wants to go with the AWS Lambda function to partition your data and to customize something, you can always refer to this link. I will also provide the link, this reference link in the description below. So now let's first understand the concept of the inline parsing. In case of inline parsing, AWS Kinesis Data Firehose or the delivery stream uses the inbuilt mechanism JQ parser to extract the keys for partitioning from the data records itself. And as of now, we have the data in the JSON format. So we will go with the inline partitioning. So which key we are going to use for the partitioning? So we have the 5 total keys: student ID, name, age, major, and GPA. And we have the total 4 types of measure. I will quickly go through those majors. One is the computer science, math, engineering, and physics. So the students belongs to this university for either fall into one of these major. So it is good to go with the partitioning based on the measure itself. So I'll go with the partitioning based on the measure. And within that measure, I will go with the year, month, day, and the hour basis so that I can see in which hour I get the data of particular student. And out of this partitioning, like measure, year, month, day, and hour, this all five partitioning lies under one partition, which is student info. Why this one parent partition is needed, you will get to know about it once we start learning the Athena and the glue concepts. But yes, as of now, we are going to partition the data based on the measure only. So to partition the data, we need to use this kind of the expression, where we are having the first parent partition as the student info, under which we have the second partition measure, which we need to extract from query itself, like extract from the data itself. And within the data, we have the key as the measure. So that's why I have choose the measure here. Then the year, which will be the timestamp, the current timestamp, month and day, date and hour will be extracted from the current timestamp only. So let's go to the AWS account and uh, start looking into this. But we can't alter the current Kinesis delivery stream or the data firehose, because when we need to enable the dynamic partitioning, it can be only possible when we create the Kinesis data firehose for the very first time. So to do this, I need to again create the Kinesis data firehose. So let's quickly go and create the Kinesis data firehose over the AWS. So I'll go to the Kinesis service of the AWS. I'll go to the delivery stream. As of now, we don't have any Kinesis data firehose because I have deleted the earlier one. The source will be Kinesis data stream. The destination will be Amazon S3. And we have the Kinesis data stream as code hex stream 01. Let's name this Kinesis Firehouse as Kinesis Firehouse delivery stream 01. Okay, so as of now, I don't want the transform source records with AWS Lambda. I will not going to enable it. The destination will be our S3 bucket, which is the raw bucket we are having. Let's choose this. And I'll enable the dynamic partitioning now. So when we enable the dynamic partitioning, we need to also enable the inline. We are going with the inline parsing for JSON mechanism. So I'll enable it. And when I'm enabling it, I need to first write which key I need to partition on. So I'll partition based on measure. So the example record they have shared here is that if we are having this kind of JSON records and we wanted to like dynamic partitioning, if we wanted to enable it for the customer ID, we can directly go and enable the partitioning as dot customer ID, because it don't have any parent key defined here. But like this is the nested JSON, which the type is the parent key and device is the child key. So if we want to enable the partitioning based on the device, we need to enable it as dot type dot device. So this is how it will going to be work. So as of now, for measure, we don't have any parent key out here, so we can directly enable it as measure. And that's it. And in the S3 bucket prefix, we need to add this expression out here. So we have added this expression here. And for error prefix, like if there is erroneous record, it can go under the S3 bucket error prefix. The retry duration for any kind of the error is the 300 seconds. Let's create a buffer. So the minimum size of the buffer here is the 64 MB in case of the dynamic partitioning. So I'll go with 64 MB. And the buffer interval will be the 60 second in our case. So if either of these two conditions met, the data will going to be land into the S3 bucket raw folder. So I'll enable the S3 bucket encryption here only, and I'll create the delivery stream. So now our delivery stream is getting created. So meanwhile, we're going to clear the S3 bucket data. So as of now, we have this type of partitioning. I'll go and delete this folder permanently. So let's delete this folder permanently. So this folder is now gone. We don't have any data in our S3 bucket. I'll go and regenerate the IAM credential for our Kinesis data stream. So for this, I'll go to the IAM user, which I have, and the security credential. I'll regenerate the access key. So let me just refresh it very quickly. Okay, we have the access key already created. I'll go and deactivate this access key. And for deletion, I need to enter this. So I'll do this, and I'll recreate the access key. I'll create the access key for the application running outside AWS. I don't want to add any tag as of now, and our access key is generated. So this is the access key. I'll paste it here directly. So yeah, this code is already available on my GitHub repository. I'll provide the link of this code in the description below. So I'll copy and paste this access key and secret ID out here, and done. Continue. Okay, so now we are ready to produce the data. Let's first see if our Kinesis delivery stream has been created. Yes, we have the delivery stream now, and our S3 bucket is currently empty. Okay, so let's reproduce the data into our S3 bucket. I will go and produce the how many number of records I'll produce. Let's produce the 50 number of records as of now. I'll go and run this. So I'm producing the 50 number of records here, and all the records are getting successfully sent to our AWS Kinesis data stream. So now we have the data inside our Kinesis data stream. Now, since we have already set the buffer hints to be 60 seconds, so we need to wait for at least 60 seconds to get our data arrived here. So yes, now we have our data in our S3 bucket, and the way we have created partition here is uh, we have created the dynamic partitioning student info, then we have created the partition based on the measure, then the year, month, day, and the hour. So if I go, student info is there. The next partition is based on the measure. So we have the 4 different kinds of the measure: computer science, engineering, math, and physics. And the data for the particular measure, like if the student belongs to the computer science measure, then the data of that student should be present inside this particular partition only. So it is under the right partition in R. So let's quickly go and query this data with the S3 select as of now. So we can query this data, and let's see, the measure is computer science for all the 4 students here. And let's verify it for physics major students. So let's quickly go into the physics partition and query this data with the S3 select. And the data is present in the form of the JSON. So we need to run the SQL query, and yes, all the students present out here belongs to all the students present out here belongs to physics major only. So yes, our partitioning is working successfully, and this is how the data needs to be partitioned, because if we have the efficient partitioning in our S3 bucket, it will result in the faster query execution, and it will also reduce the cost of the Athena and the S3 bucket, because Athena is going to uh, cost as per the number of records it is scanned or the number of files it scanned per query. So it will reduce the Athena and the S3 costing, as well as it will return the result of the query very quickly, because we have partition data very efficiently. So this is how the dynamic partitioning works, and it is a very good concept. So now we can move to the next chapter of this particular lecture series, in which we will going to create the glue data catalog on top of this S3 data, and then make this data queryable via the Athena engine. So stay tuned for more updates.